Welcome back to the deep dive. Uh, we have a pretty fascinating stack of papers on the desk today, and I have to admit, when I first saw the title of the main presentation, I almost put it in the maybe later pile.
Oh, really?
Yeah. It's titled The Anatomy of a Decision, which just sounds a bit vague, but then the subtitle caught me.
Deconstructing the trolley problem from intuition to algorithm.
Exactly. And, the trolley problem, it's kind of
It's the wonder wall of philosophy.
yes, it's the classic dinner party buzzkill. Everyone knows it. Everyone thinks they know how it ends.
Right. It's been played to death in freshman dorms.
Totally. But as I started digging into this specific source material, I realized this isn't just a rehash of Philosophy 101. We aren't talking about guys in togas debating abstract concepts anymore.
No, not at all.
The sources today are actually taking this hypothetical nightmare and dragging it into a very sterile, very real engineering lab.
And that is the key shift here. For decades, this problem was just a way to test undergraduates. Now it's literally a way to test safety features in 2-ton machines that move at 60 miles an hour.
Right.
We are moving from what would you do to what must we code.
So for the listeners who have somehow managed to avoid pop culture for the last 50 years, let's just quickly set the scene. The source material provides this very clean clinical graphic called the scenario.
But forget the graphic for a second and just picture the reality of it.
Right. Picture you're standing by a train track. A runaway trolley is just barreling down the line. It's massive. It's loud. The brakes are completely gone.
And the stakes are immediate.
5 people are tied to the track ahead. They're going to die if the trolley keeps going. But you're standing right next to a lever.
Just waiting to be pulled.
If you pull it, the trolley switches to a sidetrack. The catch is there's one person tied to that sidetrack.
And it's a closed loop. There's no third option here. You can't screen. You can't jump in front of it yourself. The source really emphasizes that the system is entirely binary.
And the fundamental question for you, the listener, is simple. Do you pull the lever?
It sounds so simple. And if we look at the initial intuition poll and the data provided, most people, when pressed, say they would pull it.
Yeah.
But the data also shows something else, a massive hesitation time. People don't just say yes immediately. They flinch.
And that's what I really want to dig into first. Because mathematically, this shouldn't be a hard question at all.
Right.
The source even has a slide literally called, "This is not a math problem." But, isn't it? 5 is greater than 1. If I'm a triage nurse or a military strategist, I'm saving the 5. It feels like the only logical move.
If you were a computer, yes. It's a simple inequality. 5 is greater than 1. Solve for x. But the reason this deck is titled The Anatomy of a Decision is because it argues that human decision-making is structural. It's not just arithmetic. We have what the source calls the architecture of human psychology getting in the way.
Architecture of human psychology, which sounds fancy, but what does it actually mean in practice? Is it just guilt?
It's way deeper than guilt. The source breaks it down into 2 major barriers. The first is the action versus inaction bias.
Okay.
This is huge in behavioral economics, not just philosophy. Humans have a profound evolutionary preference for the status quo. We actually prefer the harm that happens to us rather than the harm we actively cause.
Wait, can you give me a real-world example of that? Because I feel like if I saw people in danger, I'd want to act.
Sure, think about investing. Let's say you have money in a standard savings account and inflation is just eating it away. You are losing money by doing nothing.
Right.
But taking that money and putting it into the stock market feels inherently risky. If you put it in the market and lose 10%, you feel like an idiot. You feel responsible. But if you leave it in the bank and inflation eats 10% of its value, you just shrug and blame the economy.
Oh, wow. That hits home. Losing money because I made a bad trade feels infinitely worse than losing money because I just didn't pay attention.
Exactly. That is the bias at work. In the trolley scenario, standing there and doing nothing effectively kills 5 people.
Yeah.
But psychologically, you can tell yourself, I didn't do that. Feet did that. The trolley did that.
But if I pull the lever...
Then you did it. You intervened. You became the author of the story.
Right. And that leads to the second barrier mentioned in the slides, which is emotional framing and the visceral weight of the act.
Yeah, the slide talks about the massive difference between allowing a death and causing one.
It's the difference between watching a tragedy unfold and being the weapon itself. When you pull that lever, you are physically condemning that one person on the sidetrack.
And your brain just screams that this is wrong, even if your calculator says it's right.
Precisely. We're wired to avoid direct harm, even if it serves the greater good. So we basically have this internal civil war going on. The logical brain is shouting, save the 5, and the lizard brain is shouting, don't touch anything.
And we just freeze.
And that freeze is what philosophers have been trying to thaw out for centuries, right?
Right. Since we can't rely on our gut, because our gut is utterly conflicted, we built ethical frameworks to help us navigate.
And the source material outlines the two heavyweights here. We have the utilitarian view and the deontological view.
Yes.
I remember these from college, but the source presents them in a way that feels a lot more applied. Let's start with the utilitarian side. The graphic shows a set of scales.
Right. So utilitarianism is basically the engineers of ethics. It's entirely outcome-based. The core tenet is that the morality of an action is determined solely by its consequences.
The greatest good for the greatest number.
Exactly. To a strict utilitarian, the trolley problem is barely even a problem. You have a variable of -5 lives or a variable of -1 life. You choose -1, you pull the lever.
Because the focus is entirely on the outcome.
The how doesn't matter, only the what happened matters.
But wait, let me play devil's advocate here. If we run society purely on utilitarianism, doesn't that get dark really fast?
It gets incredibly dark.
Like, if I'm a perfectly healthy guy walking into a hospital for a checkup, and there are 5 people in the ICU who need organs, a heart, a liver, 2 kidneys, a lung, a strict utilitarian doctor should technically knock me out and harvest my organs.
1 dies, 5 live, net positive.
Right, which is terrifying.
And that is the classic counterargument. That exact terrifying logic is why the second framework exists, the deontological view.
And the source uses an icon of a rule book or a shield for this one.
Because deontology is rule-based. It argues that some actions are inherently wrong, regardless of the consequences or the net lives saved.
So it doesn't matter if it saves 5 people or 5 million people. You cannot commit a moral atrocity to get there.
Exactly. The rule isn't do not kill unless it's Tuesday and you can save a bunch of people. It is just do not kill.
So in the trolley problem, a deontologist looks at the lever and says, if I pull that, I am killing an innocent person. I cannot do that.
And so they do nothing.
And 5 people die.
Yes. But the deontologist argues that the moral agent, you kept your hands clean, you followed the rules. The tragedy of the 5 deaths is the fault of the trolley, not the fault of the bystander.
To quickly recap the decision matrix from the slides then, if your action is to pull the lever, the result is 1 death, and that makes you utilitarian.
Correct.
But if your action is to not pull the lever, the result is 5 deaths, and that makes you deontological.
Right. Completely opposite answers to the exact same problem.
And it seemed like we just flip-flop between these two constantly in real life.
We do. We are usually deontologists with our family and friends. We say, I won't lie to my spouse, I won't steal from my neighbor.
Right.
But we tend to be utilitarians in public policy. We say we need to raise taxes on this group to build a hospital for that group.
Oh, that makes sense. We accept trade-offs at a macro level that we would never accept at a micro level. And that is where this source material takes the sharp turn I mentioned at the beginning. Because up until now, we've been talking about human hesitation, human guilt, human flip-flopping.
Philosophy.
Right. But the next section of the presentation is literally titled Coding Morality.
This is where we leave the philosophy department and enter the R&D lab of an autonomous vehicle company.
The visuals change completely here too. Gone are the isometric drawings of a cartoon trolley. Now we're looking at a 16:9 Swiss rationalist-style graphic that looks like a heads-up display from inside a self-driving car.
It's got bounding boxes around objects, LiDAR scans, speed readouts.
And the scenario is basically the same, but the context is radically different. The car is driving. It detects an unavoidable accident. Let's say a truck swerved into its lane. Probability of collision is 98%.
Right.
The car calculates and have 2 options. Swerve onto the sidewalk and hit a pedestrian, or stay in the lane and crash, potentially killing the 5 passengers inside.
And there's a text overlay on the slide that shows actual code snippets. Well, pseudocode, obviously.
Yeah, it says switch ethical framework, and then it has case utilitarian, save max, break, and case deontological, avoid action, break.
Now, I want to be clear here because I know we have technical listeners.
Yeah.
No self-driving engineer is literally writing a switch statement that says, if utilitarian, kill pedestrian. That's not how machine learning works.
Yeah, it seemed a little too clean when I saw it. So what is the reality?
The reality is much more complex and, frankly, much more interesting. Engineers are effectively hard-coding moral philosophy into software using what are called cost functions.
Cost functions.
Right. The AI is constantly running simulations thousands per second trying to find the path of lowest cost.
But cost here doesn't mean money.
No, cost is a penalty value assigned to bad outcomes. Hitting a traffic cone might have a cost of 10. Hitting a dog might have a cost of 1,000. Hitting a human might have a cost of 1,000,000.
The car is just programmed to choose the path with the lowest total number.
Yes.
So if the choice is kill 5 people in the car versus kill 1 pedestrian, and every human life has a cost of 1 million.
Then the math is simple. 5 million is a higher cost than 1 million. The car swerves. It behaves like a utilitarian. It's a minimize harm algorithm.
But wait, that implies that someone, somewhere, had to assign those numbers. Someone had to type into the system that a pedestrian is worth X and a passenger is worth Y.
Exactly. And that is what the slide with the pseudocode is really getting at. It's not about the literal syntax. It's about the architecture of the decision. We are taking moral philosophy and turning it into a math problem.
Which brings up a massive difference between the human on the tracks and the computer in the car. We talked about action versus inaction bias earlier. We talked about how humans freeze, but the car doesn't freeze, does it?
No. And this is the most critical distinction. Humans suffer from latency. We panic. We have that visceral weight we talked about.
Right.
A machine has zero latency and zero emotion. It doesn't feel the weight of the lever. It just executes the function.
So in a weird way, the machine solves the action bias problem. It won't hesitate to pull the lever if the math says so.
It solves the hesitation problem, but it amplifies the ethical problem. Because a human driver who crashes in a panic is reacting. We forgive them because they didn't have time to think.
But the car always has time to think.
It processes at the speed of light, so whatever the car does, swerving or staying, is a premeditated decision.
Wow. That is chilling. Every accident becomes a premeditated choice.
It becomes a calculated execution.
So let's look at the reality check slide in the source. Because it mentions that engineers are currently grappling with this split-second calculation issue. It's not hypothetical anymore.
If I
buy a car, and I'm sitting in the back seat. I want that car to protect me. I want it to prioritize the passengers.
Of course you do. That's the self-preservation setting. But imagine a car company marketing that. The new Model X, now with aggressive pedestrian sacrifice mode to keep you safe.
Yikes. Yeah, that's not going to look good on a billboard.
But the alternative is, the new Model X, it will drive you into a concrete wall to save a school bus. Who buys that car?
I certainly wouldn't. Hey, honey, I bought the car that's programmed to kill me if the math adds up.
So we have a market force pushing for self-preservation, which is essentially deontology for the driver, and a societal force pushing for utilitarianism to save the most lives overall. And the poor engineers are stuck in the middle trying to tune these cost functions.
It really highlights that we aren't just teaching cars to drive. We're teaching them to value life, and we can't even agree on how to do that ourselves.
We're trying to code a solution to a problem we haven't even solved in philosophy class yet. We're basically hard-coding our own confusion.
Which brings us to the final slide in the deck, and I think it lands this plane perfectly. It's just text on a black background. It poses a question that circles back to the very beginning.
It's the question that haunts this entire field.
Is killing by action morally different than killing by inaction?
We talked about this with the human on the tracks. We feel like doing nothing is safer. But when you translate that to a machine, the concept of doing nothing evaporates.
Wait, what do you mean?
Yeah. Well, for a computer, staying in the lane is a command just as much as swerving left is a command. It requires energy, processing power, and execution.
Oh, I see.
The car cannot do nothing. It can only execute one line of code or another line of code.
Wow, so this distinction between acting and letting happen just doesn't exist for AI?
It doesn't. Every outcome is an action, which means the action bias, that safety net we humans use to sleep at night, is completely gone.
That puts the burden right back on us, not on the car, but on us, the people buying them, the people regulating them.
Think about it. If you buy a car that is programmed to strictly follow the rules, stay in the lane, never cross the double yellow, and because of that, it hits 5 people instead of swerving. Did the car kill them, or did you kill them by choosing that algorithm?
That's a really heavy question to leave on the table, and it actually makes me think about something that wasn't even in the slides but builds right off this. Think about the terms of service we all just blindly scroll past. One day, buried in paragraph 400 of your car's software update agreement, there might literally be a checkbox. Prioritize passenger or prioritize total lives.
And clicking accept on that might be the modern version of pulling the lever.
It's a lot to process. We went from a cartoon trolley through the messy wiring of deep psychology and ended up staring at the cold logic of an autonomous future. It really illustrates how difficult it is to translate human intuition into binary decisions.
The technology is almost the easy part. The hard part is looking in the mirror.
Well, on that cheerful note, that is a wrap for this deep dive into the anatomy of a decision. Remember that how you answer these moral questions might literally determine how you think your car should be programmed.
Just keep your hands on the wheel for now.
Will do. Thanks for listening, everyone. Stay curious, and we'll catch you on the next deep dive.